Imagine Europe in late 1944, a continent scorched by total war, with whole cities reduced to blackened shells and the night sky torn by the glowing lines of anti-aircraft fire. Allied bombers pushed deeper and deeper into the heart of the Reich. The Luftwaffe, once a symbol of speed and terror, now survives on scraps. Too few pilots, too little fuel, too many enemies. And yet, in a quiet corner of Germany, far from the collapsing front lines, a pair of brothers are building a machine that looks like it tumbled out of the future. No tail, no fuselage in the way we know it. Just a smooth, predatory wing made mostly of wood, driven by jet engines and shaped to slip past radar like a shadow in fog. The Horten Ho 229, a superplane conceived by visionaries, rushed by desperation, and just when it might have mattered, vanished. To understand why this airplane became a legend, you have to understand its world, what Germany needed, what it had lost, and what it still believed it could do. At the start of the war, the Luftwaffe was built on fast, agile fighters and tightly coordinated tactics. In 1940, Bf-10-9s and Bf-11-9s tore across European skies. In 1941 and 1942, they still held their own. But by 1943, the balance had shifted. The British and Americans brought numbers and industry to the fight. Radar networks, long-range escort fighters, and an industrial base that could replace losses faster than Germany could manufacture hope. The P-51 Mustang changed everything. It could escort bombers to Berlin and back. The RAF's night bombing matured into a brutal science. The USAAF's daylight raids, once suicidal, learned to cut through Germany's defenses with fighters that were fast, high-flying, and relentless. The Luftwaffe had a choice: die slowly on familiar ground or gamble on something radical. It gambled. Germany pushed into jets with the Me-262 and Arado 234. The idea was simple but seductive. If you can't win the numbers game, win the physics game. Jet speed promised to break interception windows, to turn a bomber stream into a set of targets that could never be lined up, to make a fighter too fast to catch and too quick to pin down. On paper, it made sense. In reality, the jet engine of 1944 was a fragile animal. The Jumo 004, the engine that would power both the Me-262 and the Horten Ho 229, was a marvel and a headache. It used scarce materials. Its turbine blades suffered under heat. Under combat conditions, it might last dozens of hours, sometimes less, before the metal simply gave out. That was the cost of being first. Into this storm stepped two men who were not typical Nazi engineers. Reimar and Walter Horten were glider artists before they were war engineers. They loved the clean lines of flight, the feeling that a wing could carve into air with almost no drag, no wasted motion. They had a simple belief: if you want to go far and fast, make the airplane nothing but a wing. Every surface that sticks out creates drag. A tail is a compromise from a world that doesn't trust aerodynamics to behave. The Hortens did. As young men, they built flying wings that were so elegant, so quiet on the wind, that even a country hurtling toward war had to take notice. Their idea found fertile ground as the Reich grew desperate for wonder weapons, Wunderwaffe that could flip the chessboard with one dramatic move. Some of those projects were fantasies. Others, rockets, jets, guided bombs, were chillingly real. The Horten proposal was not a rocket-powered dream or a giant tank. It was a clean, physics-driven answer, a jet-powered flying wing. 2 engines, minimal frontal area, low drag, a smooth blended shape that would present less to radar and less to the wind. To modern eyes, it looks obvious. In 1943, it looked alien. The Air Ministry agreed to a prototype. It would begin as a glider, the V-1, to test the aerodynamics without the chaos of new engines. The V-1 proved the wing could fly. Then came the leap, the V-2, a powered, jet-driven version. The cockpit sat like a teardrop at the leading edge of a wide-swept wing. The engines were tucked into fairings. There was no vertical tail to steady the yaw, no conventional stabilizer to make the pilot's job easy. Control came from careful distribution of surfaces across the wing, from elevons and subtle aerodynamic tricks that demanded both precision and nerve. And in a detail history would later obsess over, the airframe was built largely of plywood, layers of wood impregnated with special resins and adhesives. Some accounts describe those adhesives as having charcoal content. Some engineers later argued that, intentionally or not, they created a degree of radar absorption. Whatever the exact chemistry, the shape and materials together reduced how the airplane would return a radar signal. Not invisibility, but less time for a radar operator to see the wing, call a vector, and set an intercept. When the V-2 flew, it did not announce itself with the roar of triumph. The flight ended in tragedy. Test pilot Erwin Ziller took the aircraft into the air, and at some point in the test, one of the engines failed. Accounts vary on the exact sequence that followed, what rolled first, what control inputs were made, what altitude remained, but they agree on the end. The airplane went in, and Ziller died. In another program, at another time, that might have been the end. In 1944, Germany, it was a terrible setback and a trigger to push harder. The wing could fly. The jet could push it. A pilot had died, but the logic of desperation said, continue. Production responsibilities shifted toward Gothair Wagenfabrik and the V3. An improved pre-production configuration took shape. Even on paper, its numbers were chilling. Speeds over 600 miles per hour were projected. In level flight at altitude, almost nothing the Allies had in theater could catch that. A Mustang might top 440 miles per hour. A Spitfire might touch the upper 300s. The British Meteor was fast but rare and still maturing. The idea that a wooden wing could outrun the best Allied fighters was intoxicating and credible. The Allies had reason to worry. If put into service as a fighter, the Horten could slash into bomber formations and be gone before an escort could get lined up. If used as a bomber, it could slip through radar nets that were tuned for conventional shapes and speeds and strike targets with less warning. In the age of radar, a few seconds matter. A few seconds can be the difference between guns ready and guns cold, between a fighter climbing into position and a fighter still turning on his oxygen. But a war is not a test stand. The same factories that might have built a fleet of flying wings were being pounded by 500 and 1,000-pound bombs. The same rail lines that might have delivered components were twisted metal under the winter sky. The same fuel that might have fed the Jumo 004s was being burned just to keep existing units in the air. The Horten program in early 1945 was a study in contradiction. A cutting-edge machine pushed forward by a country with a broken supply chain. Yet it advanced. Drawings became molds. Molds became airframes. Airframes mocked the logic of collapse by simply existing. In that same final year, Germany's jet revolution showed both its power and its fragility. The Messerschmitt Me-262 entered combat in meaningful numbers and terrified bomber crews. Pilots who managed to get a clean pass could cut a B-17 or Lancaster apart and then climb away in a streak. But the 262 had handicaps no tactic could erase. Engines that failed, runways that were watched and bombed, a dictatorship that demanded bomber versions and delayed fighter deployment. There were 262 OS that never reached their squadrons because they were destroyed on the ground. There were pilots trained too quickly because there was no time to learn the subtleties of jet throttle and energy, and over all of it, a sky increasingly owned by the Allies who learned to attack jets at their weakest, on takeoff and landing when they were slow, hot, and vulnerable. The Arado R-234, the world's first operational jet bomber, showed another path: speed as survival for reconnaissance and precision raids. It darted over enemy lines at altitudes and velocities that made interception a game of luck. But it was a specialist tool, and the war demanded hammers. The Heinkel He-162, born as a people's fighter to be churned out in wood, became a tragic symbol of the limits of industrial fantasy. It was fast, dangerous, and unforgiving, often flown by boys with too little training. In every direction, the Luftwaffe's last gamble revealed the same truth. Jets were the future, but the future needed time the Reich no longer had. The Horten Ho 229 sat at the intersection of these lessons. It was faster than a piston fighter. Its shape promised a smaller radar return. Its materials were chosen partly because aluminum was scarce, and partly because wood, when layered and treated, could be both strong and light. The brothers reached for an answer that used what Germany still had: craftsmanship in wood, adhesives, experience shaping gliders, combined with the brute novelty of jet propulsion. A flying wing does not forgive easily. Without a tail to damp yaw and pitch, every gust and every throttle change matters. The sweet spot between smooth and skittish is narrow, but when you hit it, you get something glorious: less drag, more performance, and a profile that looks like it's cutting space rather than pushing through it. The Allies were not blind to this. Intelligence reports late in the war mention a jet-powered flying wing under construction. Reconnaissance photos, prisoner interrogations, and fragments of memos painted a picture that was frightening because it made sense. The British radar network that had saved the United Kingdom in 1940 now extended across Western Europe. The Americans used mobile radar units in the field. The Soviets grew their own capabilities. Yet radar then was not what radar would become. It had blind spots, lags, assumptions baked into doctrine. A smooth, swept wing with carefully blended inlets and minimal vertical surfaces reflects radio waves differently than a conventional fuselage with a big tail. The time from first blip to confident track could lengthen. The moment in which a controller says, "Turn to heading 030 Angels 20," could slip by a beat. In air combat, a beat is enough. When American troops entered Gotha in 1945, they found evidence of a machine that matched their fears and their curiosity. The V-3 airframe was far along. There were jigs, plywood skins, engine mounts. The Americans crated what they could: wooden ribs, metal fittings, drawings, and shipped them home. In the scramble to seize everything of potential value, the Horten was just one prize among many. V-2 rockets, jet engines, swept wings, radar sets, even entire factories. The Americans called their scientific salvage paperclip, a bland word for an extraordinary rearranging of talent and technology across continents. The British collected what they could. The Soviets did the same, often with more force than formality. Engineers who had built a Nazi arsenal now built for other flags. In the United States, the Horten crates landed in a world that barely had the bandwidth to process them. There were other priorities: atomic weapons, long-range bombers, a new air force, jets that could break the sound barrier. The Horten wing sat in storage, in parts, in pieces, in a kind of suspended animation, while American designers pursued their own flying wing dreams. Jack Northrop, long obsessed with tailless aircraft, built the experimental YB-35 and YB-49 bombers, giant flying wings that showed both brilliance and instability. They were gorgeous and moody machines. The Air Force turned away, choosing conventional bombers that fit the old logic. But the seed was planted. Decades later, a new generation of engineers would revisit what the Hortens attempted. In the Cold War, as radars grew sharper, as missiles grew smarter, the question returned. What if you could cheat the radar with shape? What if you could build a bomber whose form and skin and edges were all conspiring to scatter radio waves away from the receiver? The full answer, faceted stealth, would arrive much later, with optimized geometries, composites, RAM coatings, and computer-controlled stability. But the intuition that shape itself is a weapon was there in the Horten brothers' workshop. A smooth wing, blended edges, no tail to light up a radar scope. Their materials were primitive by modern standards. Their adhesives were more luck than lab-validated stealth. Yet the experiment worked in the direction history would take. As the Smithsonian began to examine the surviving Horten 5-3 in the 2000s, something fascinating happened. Engineers built a replica with the right shape and tested how radar would see it. The results weren't magic, but they were real. Against radars of the 1940s, that wing would have been less visible than a conventional fighter or bomber. Not invisible, simply harder to catch in time. That's sometimes the only margin that matters. Enough delay to break the chain of detection vector intercept. Enough uncertainty to arrive, strike, and leave. Could the Ho 229 have changed the war? That's the intoxicating question. It suggests a single machine as a lever to move history. It's tempting to say yes. A squadron of flying wings slashing bomber formations, sowing panic, forcing new tactics, buying the right time. But wars rarely yield to one variable. Germany in 1945 lacked fuel, pilots, airfields, machine tools, strategic freedom. Even the Me-262, which did enter combat and did kill, could not bend the arc of defeat. The Horten would have faced the same constraints. A handful might have flown, a handful might have scored. And then they would have needed spares, engines, and training hours that no one could give them. The Allies would have adapted. More patrols near known fields, radar recalibrations, fighters stationed to pounce on takeoff and landing. That's how air wars work: a move, a countermove, and resources to support the pattern. Germany had run out of resources. What the Horten could have changed was psychology. Every war carries a theater in the mind. If even a few missions had succeeded, if Allied radar crews had been caught by a wing that seemed to appear out of nowhere, if bomber squadrons had been mauled by something their briefings dismissed as improbable, the shock would have echoed. Doctrines would have shifted. The myth of Allied invulnerability over Germany would have cracked a little. It wouldn't have saved the Reich. It might have written a few darker pages on the way down. There's another version of this story that runs east instead of west. Some records suggest more than one Horten airframe existed at war's end. One went to America. Others may have been destroyed. It's possible at least one fell into Soviet hands. In the late 1940s, Soviet aviation leapt forward in engine design and swept-wing aerodynamics, often with the help of German engineers working in the USSR under varying degrees of coercion. Whether a Horten wing ever sat in a Soviet hangar is a matter of rumor and inference. What we do know is that the aerodynamic logic the Hortens trusted, lower drag through tailless design, was not theirs alone. Northrop on one continent, the Hortens on another. Separate minds, pulling on the same thread. History sometimes rhymes by convergence. The human story can get lost in the engineering. Walter Horten would later return to the newly formed West German Air Force. Reimar, the younger brother and the deeper dreamer, left Europe for Argentina. There, he continued to draw and build and argue for the beauty of wings without tails. He never stopped believing in what he'd seen in the air as a young man, that if you reduce the airplane to its essential shape, the air does the rest. He died decades later, still defending the claim that his wartime wing could have done more if only it had been given the chance. It's easy, in peace, to judge the confidence of those who built in war. But inside the fever of 1944, confidence was the only fuel that didn't run out. To make a viewer stay, storytelling must return to first principles, people, stakes, and choices. The Horten story has all three. The people are two brothers who believed in a shape. The stakes are a war the world could not afford to prolong. The choices are those of a regime that backed wonder weapons because it had no other cards to play, and of engineers who tried to design their way out of an apocalypse. You can feel the contradictions in the wood grain of the V-3, a high-tech aircraft built in a country that had run so low on metal that even airframes became furniture. You can feel the craft in the joins and layers, the way a glider builder watches weight and stiffness like a poet watches words. And you can feel the sadness. A brilliant object built for a horrific purpose, saved by the fact that it was finished too late to be used for worse. No airplane exists by itself. The Ho 229 sat in a constellation of late war machines that tried to drag the Luftwaffe out of the past and into a jet-shaped future. The Me-262 proved the fighter concept, the R-234 the bomber. The He-162 proved that speed alone cannot replace training. Other ideas flickered at the edges, tailless interceptors, rocket fighters like the Me-163 Comet that could climb like a bottle rocket and then glide home, terrified and unmotorized. All were threads tying into the same knot: speed, altitude, surprise. The Horten wing promised all three in one graceful shape. It is not an accident that when the United States finally built a stealth bomber for the nuclear age, it looked like a polished memory of the Horten's form. The B-2 is not a copy. It is what happens when the same problem is solved with next-generation tools, powerful computers, composite skins, fly-by-wire stability, and a century of lessons about how air peels around a wing. Spend a moment with the technical heart of the Ho 229, because that's where myth becomes machine. The wing sweep reduced drag at high speed and kept shock waves at bay, as the airplane neared transonic regimes. The absence of a vertical tail removed a major contributor to radar cross-section and cut parasite drag, but it forced the designers to rely on yaw stability from wing sweep, dihedral effects, and careful control mixing. Elevons, surfaces that combine elevator and aileron functions, managed pitch and roll. Drag rudders or split flaps at the wingtips could help with yaw and braking. The engines, the Jumo 004s, sat near the centerline, reducing asymmetric thrust effects, but complicating inlet design and boundary layer behavior. A wooden skin, bonded over a structural framework, offered weight savings and fast production with the materials available. If some adhesives genuinely included carbon or other radar attenuating elements, it would have been an accident in service of an advantage, a crude first-generation RAM before the acronym became common. Imagine how it would feel to fly. You sit slightly forward of the wing's center of pressure, looking out over a horizon that seems wider, because there's no tailplane chopping the sky into pieces. At takeoff power, the engines are noisy but not thunderous. They whine and surge, more industrial than animal. As you rotate, the wing feels light, almost eager, and then you must tame it. Keep the yaw in check, keep the pitch honest, ride the energy rather than kick it. In climb, the speed comes on differently than in a piston fighter. There is no heaving engine up front, no torque to fight, only a push and a resistance that feels like it moves away from you rather than pushes back. At high speed, the wing settles into a rhythm. It loves smooth inputs. It hates panic. A good Horten pilot would have been part artist, part engineer, and part gambler, trusting the air to cooperate with a shape that gave him almost no margin for clumsy moves. When the Smithsonian's restoration team began to assess the V3, they met a paradox, a priceless artifact built from materials that hate time. Wood warps, glues dry, crack, or creep. Metal fittings corrode. The very thing that made the Horten possible in wartime, wood, made it hard to preserve in peace. And yet, even in silence, the airplane teaches. Students and engineers who stand under its wing learn to see aerodynamics not as equations first, but as sculpture with purpose. The line from leading edge to trailing edge is not decoration, it's a decision. The absence of a tail is not an omission, it's a bet. And the fact that all of this sat under camouflage paint while a country burned tells you something about the human capacity to build beauty in terrible places. There is a darker part of this story, and it is essential to tell it plainly. This airplane, like every German weapon of the period, was built for a regime that waged a genocidal war. The brilliance of the Horten brothers does not redeem the crimes of their state. Technology is always haunted by the reason it was funded. If the Horten had flown in numbers, it would have killed Allied air crews defending a world that had to survive. Admiration for the engineering must live beside clarity about the politics. One of the healthiest things about the Ho 229's fate is that it arrived too late to hurt more people. Its influence did its work later, under different flags, in a world that, however imperfect, used stealth as a deterrent rather than as a last gasp of a collapsing dictatorship. So why did this aircraft terrify the Allies? Because it attacked their confidence. The Allied air campaign by late 1944 was a machine of statistics, sorties, loss rates, fuel consumption, tonnage on target. Confidence is the grease in that machine. If radar suddenly needed more seconds, If fighter controllers had to second-guess blips, if bombers started falling to a wing that never should have been there, confidence would leak out of the system. Pilots would fly tighter, escorts would be pulled from other duties, timetables would slip. Nothing collapses immediately, everything slows. In the aggregate, that's danger. The Horten promised to inject uncertainty into a campaign that lived by certainty. And why did it disappear? Because the war ended, because the Allies walked into the hangars and took what they could carry, because the rest was burned, bombed, or abandoned, because post-war priorities buried it under more urgent projects, because wood and glue do not age kindly, because stories need time to ripen. And this one spent decades in a crate. When it re-emerged, the world it could have changed was gone, and the world it influenced couldn't quite admit the debt. That's how many important things live in history, not as heroes on parade, but as ghosts in footnotes, waiting for someone to notice the outline they left in the dust. If you want a single sentence to hold on to, take this one. The Horten Ho 229 did not win a war, but it won an argument. The argument that shape is power. From that argument flowed B-2s and F-111s and a generation of radar-evading craft whose job was not to be beautiful, but to be unseen. And because humans are humans, because we care how things look even when they are built to disappear, those machines echo the Horten's grace. You can see the family resemblance across time, the refusal of a vertical tail, the tenderness with which leading edges are drawn, the sense that the airplane is not a thing you bolt together, but a surface you persuade the air to love. Think back to the brothers who gave this form its first chance. Walter, the pilot, trusted his hands. Reimar, the designer, trusted his lines. They did not set out to make a stealth jet. They set out to make the cleanest wing they could, powered by engines that promised more than pistons ever could. In doing so, they stumbled into a kind of invisibility. You can make a lesson out of that if you like. Great inventions often arrive as side effects of better questions. Ask how to cut drag, and you might find you cut radar return. Ask how to fly farther on less, and you might find you can fly faster than those who use more. Ask how to shape the wing to tame the wind, and you might find you tame something else you didn't expect. Does that mean the Horten brothers should be celebrated? Celebrate the design. Remember the context. Genius and guilt are not opposites. They live uncomfortably together in most human achievements of that scale. The best use of their work is the one history eventually found, as a stepping stone, a case study, a wedge into a new way of thinking that could be used to keep peace as well as wage war. The artifact itself belongs in a museum where it can't hurt anyone, where it can teach without recruiting, where it can be admired like a fossil of a future that almost was. If the Allies had had more time with the Horten in 1945, more tests, more engineering resources diverted to understanding it, you might argue the stealth revolution would have begun earlier. But revolutions begin when the world is ready to adopt them, not when the idea first appears. In 1945, flight control systems were mechanical. Computing was human. Materials science was hamstrung by the very war that had accelerated it. The Horten is a time traveler who arrived early, looked around, and realized no one could speak its language yet. Look at it one last time in your mind. The wooden skin, the subtle curve, the almost organic sweep of the wing, the way the cockpit sits like an eye at the front of a manta ray. Hear the Jumo's thin metallic wail. Feel the way the air smooths out over the surface when the speed climbs past everything you've flown before. Imagine the radar operator watching a scope, frowning at a faint return that should be stronger, counting the seconds to a lock and not quite getting there. Imagine the bomber crew wondering why the contrail behind them has a shape they can't name. Imagine the fighter pilot rolling in behind a target that seems all wing and then losing it in a blink because it was never where his habits expected it to be. That's why this airplane terrified the Allies. Not because it had magic powers, but because it defied the assumptions built into their machines and minds. And that's why it disappeared, because history does not wait for you to finish your argument. The war ended, the crates closed, the world moved on. The Horten was folded into other stories: American stealth, museum restorations, YouTube thumbnails of a bat-winged ghost, until it became what it should have been all along: a lesson. Here is the last lesson, and it is not about Germany or jets or radar. It is about how ideas survive. The Horten survived not by flying, it survived by being right about something deeper than a war. The shape works. The wing can be the airplane. If you can shape a surface to please the wind, you can sometimes shape it to fool a radar. If you believe that, then the Ho 229 stops being a Nazi superplane and becomes a human claim on the future. That elegance has consequences, that economy of form is not just pretty but powerful, that the simplest shape can hide the wildest trick. When you stand before the Horten in the Smithsonian, when the restoration is far enough along to give the wing its presence again, you do not see a villain. You do not see a hero. You see a possibility cut loose from the history that funded it. That is the best fate for a weapon. To live on as a way of thinking, not a way of killing. The wing that terrified the Allies is now a teacher. The airplane that disappeared has reappeared as a ghostly mentor to machines that, ironically, try very hard never to be seen. And if you still need a closing line, take this. Victory in war belongs to those who can afford to be ordinary but relentless. Victory in invention belongs to those who can afford to be extraordinary and wrong until they are suddenly right. The Horten Ho 229 was extraordinary and wrong, then right and too late, then gone and somehow everywhere. A plane that should not have existed, proving a principle too powerful to die with it. A shadow on radar that became a shadow on history, and then finally a silhouette against a museum light, inviting us to look and to learn before it fades again into the story it changed by almost being real. But maybe the real story of the Horten Ho 229 isn't about the machine at all. Maybe it's about how humans dream when they're running out of time. The Third Reich built the Horten in desperation, but desperation and imagination are often twins. When everything is collapsing, people reach for what feels impossible because the possible has already failed them. That's what makes the Ho 229 more than an airplane. It's a mirror. It reflects how far people will go to believe in a miracle, and how sometimes that miracle ends up teaching lessons no one expected. When you stand before that black, skeletal wing, you can feel both tragedy and brilliance woven together. It's easy to condemn the world that created it, and we should. But it's also impossible not to marvel at the shape, the curve of the leading edge, the smoothness of the surface, the quiet logic that says, this is how air wants to move. It's beauty made from ashes. There's a strange irony in that. So much of human progress is born inside contradictions. We build things for one reason, and history uses them for another. The same mathematics that guided the V-2 rockets into London later took astronauts to the moon. The same engineers who built weapons for tyranny built exploration for humanity. That duality runs through the Horten story, too. A weapon that became a teacher, an instrument of war that became an artifact of wisdom. Think of what that says about us. We are a species that learns even from our worst mistakes. We take the blueprints of destruction and somehow turn them into blueprints for understanding, not because we are wise, but because we are curious. Curiosity is our greatest sin and our greatest salvation. When engineers today study the Horten, they're not copying the Nazis, they're listening to the physics, the universal language of air and motion. They're seeing how form and flow can whisper to each other across decades. They're reminded that innovation doesn't care who funds it, it only cares who understands it next. The Horten's ghost lives in every aircraft that bends radar, in every drone that slices silently through the sky. Its DNA isn't evil, it's just human, because every idea, good or bad, eventually outlives the hands that made it. Imagine a future historian 100 years from now looking back at our machines. They might find a drone or a stealth fighter or an AI-driven craft that never needed a pilot at all. They might see the same blend of genius and hubris that lived in the Horten's workshop. And they might ask the same question we're asking now. Did they know what they were building? Or were they just chasing the wind? That's the eternal paradox of invention. You can't see where an idea will lead, you just follow it, hoping it will bring light, not shadow. But light and shadow are inseparable. Every invention throws both. The Horten Ho 229 threw a long one. It darkened the skies of imagination for decades because it proved that the future could arrive too soon. It showed that technology can leap ahead faster than morality can catch up. And that's a lesson humanity seems doomed to relearn again and again. Even now, when we talk about stealth, drones, hypersonic weapons, or autonomous war, we are walking along the same thin line that the Horten brothers walked in 1944. We tell ourselves it's for defense, for progress, for knowledge. Maybe it is, but the sky doesn't care what we call it. Physics doesn't have a side. It just rewards whoever learns fastest and survives long enough to use what they've learned. If you close your eyes, you can almost hear it. A low hum in the museum hall. The echo of turbines that once promised salvation to a dying regime. The whisper of wood and glue holding together a dream that outlived its masters. It's not a sound of triumph. It's the sound of warning. Because the Horten isn't just a relic of war. It's a reminder of how close brilliance and blindness can sit together. It shows that you can be right about aerodynamics and wrong about everything else, that you can build something beautiful for a monstrous reason, that human genius doesn't ask why, it just asks how fast. And yet, even knowing all of that, we still can't look away, because somewhere inside us, we recognize the spirit that built it, that restless urge to push beyond what's known, that whisper that says, what if? Maybe that's why the Horten still captivates us. It's not nostalgia for the Reich, it's fascination with the edge of possibility. It's the same curiosity that drove the Wright brothers at Kitty Hawk, that carried the Saturn V to the moon, that will someday drive a ship toward Mars. The Horten's line runs through all of it, a thin, dark filament connecting our oldest fears with our brightest hopes. And so, when you look at that wing under museum light, don't just see what it was. See what it predicted, a future where shape is power.